hopefully keep carrying on. So for this, we need to figure out what is the minimum speed. So the minimum speed yes. So the minimum speed occurs when the centripetal force at the top is equal to what?
0.
The force of gravity.
Oh.
So the minimum speed at the top occurs when the centripetal force at the top is equal to gravity. So what we're saying there is we don't require the track to actually have a force pushing down on us. We're just going to use gravity to complete that circle.
So it gets knocked very far from the accelerator when it gets to the top, it doesn't have any gravity.
Is that like the Superman, the escape, or no?
Kinda, it's the one that goes like 88 miles an hour at the beginning.
Wait, so roller coasters don't have motors?
Something.
Yeah, some of them do. A lot of them don't. So their main drive mechanism is to get you to the top of the hill, and then you have enough energy to complete the rest of the course.
You're kidding.
Barely up there and then drop down.
I did not know.
And so I'll have to look up that roller coaster because I haven't been to Knott's Berry Farm.
We should go.
Wow.
Hey, Marcus, if it's one of us like
Make it go fund me.
wait.
All right, so FC equals FG at the top for the minimum. So FC is MAC.
Fairland City, Smart City.
FG equals MG. Right? So then we have MV squared over R equals mg. Again, we lucked out, so mass cancels out. Okay. That's why if you guys look at the roller coasters, there's no, there's a height requirement so that you can get strapped in. There's not necessarily a maximum weight requirement.
I mean, there kind of is if you can't fit in the seat.
Yeah, I did that now. They have it.
You have to fit in the seat.
So there's a volume issue, not necessarily a mass issue, right? Because you could be like hecka dense and still fit in the seat. So we have v squared over r equals g. And if we solve for v, we're going to get the square root of gr. Seems like in all these problems, that's our answer. Right?
Maybe.
There's like a tangent theta in there, or there's a mu in there.
Is
Is that how it's going to be on the test?
Is that going to be the answer choices?
Not a coincidence, but a result of the only forces that we're dealing with is gravity.
It's kind of like the whole roller coaster thing. Like when you're at the bottom of a kinetic and potential energy, when you're at the bottom, it's square root of 2gh.
Yeah, it's that type of
That type of thing. Why is there a height requirement?
All right, so here it says, what is the minimum height that the roller coaster can start from to complete the circle? So this goes back to what Alex was saying, right? Because if we have some type of propulsion system or we have some type of motor, there is no necessary minimum height. But if we're saying that the only propulsion system we have is to get to the top of the roller coaster and then that has to send us through the rest of it, then we are going to have to know what's that minimum height. Because if we guess wrong, then we're not going to complete the circle. And if our roller coaster is not holding onto the track, we definitely want to complete the circle, otherwise that ride gets really crazy. Alright?
Are we going to need to use kinetic energy for this one?
Yep. Alright, so Jasmal already figured out what we're going to use. So we're going to use energy to figure out what height we need to get this speed here. Okay, so our 2 points for energy.
Oh, we're talking about energy now, Marcus.
Oh, hell yeah.
So we're going to say that point A,
Am I going to be very clear?
so this is point A, And then the point that we are looking at is
Now you can see it.
point B.
This is so weird. Huh? This is so weird.
Now, anytime we look at energy problems, you guys should be excited because the equations are always going to start the same. Okay? So for point A, we have T1A plus UGA, and that's going to be equal to T1B plus UGB. Just as a heads up, I could ask you guys a problem where the height may be smaller than the minimum, but there's a spring that gives it some extra energy to go.
Love you too, Vargas.
So at T1A, we're going to say that that's at the point, so when you guys go on, how many of you have gone on a roller coaster? What usually happens at the top?
You stop.
You momentarily stop, like, look where you're gonna go, right? So it goes up, and then you're like just clicks in place, and you're like, oh, this sucks.
And then they take the picture too.
Right, and then it releases you down.
Wait, Marcus, what if they put you on a point at the peak and you go the opposite way? Like, what if they get you at the top and then you're actually going backwards?
Like a fake out? That would be like an ultimate scam, right? You wait for like 2 hours, you see like all these crazy loops and like missing parts for the track, and then you go all the way up, and then it just takes you back home. I like that.
It's like a super amazing.
All right, so T1A, because we know that the roller coaster is going to momentarily stop, this guy is 0. Okay, that guy is going to be 0. Because it's not like there's someone up there that pushes you down, you just slide down.
Does that mean the T initial B is also 0 or TIB?
So here we're going to have UGA, we have this guy here, so now let's substitute. So this is going to be M times G times H, we're going to say that's H minimum. H min. T1B is going to be 1/2 MV minimum squared plus MGHB.
So are we saying like, oh,
Okay, so we looked at the different types of energy that were non-zero between points A and points B.
Mr. Vargas, why isn't the T1B 0?
That's a good question. So Jasmine wants to know why is it that we don't say that T1B, or the kinetic energy at point B, is 0? Because it has to move. So if B is 0, if B is 0 up here, that means that we are stopping. We stop at the top of this loop, and we're not latched in.
So it just moves really slowly up there.
It may get down to a very slow speed, so like you go up and you barely make it, but you still have to move, because if you don't, then you're going to go up there and you're looking inverted, and then you're going to fastly see the ground approaching you. I don't know why Earth is falling towards you.
If you're gonna write it, yeah, I know.
Because of that,
Wait,
we
Vargas.
didn't have enough.
So at the peak, like at the top of the loop-de-loop, is it V0?
V is not 0. What is V?
It's small.
This guy. Because we need to be able to complete that circle.
No, at the tip of the loop-de-loop.
Yeah.
Yeah.
That's this is this. They're the same. Right? Because we figured out this is how fast we have to go in order to complete the circle. If we don't go this fast, we're not completing the circle.
And where do we find this? Is just like some regular thing? Oh no, we did it.
All right, so let's go ahead and I need to erase something because I'm running out of real estate.
Erase the American flag.
Oh.
Everything but
Chill.
Can I erase this?
Nah.
yeah.
Yes? Okay. So remember what this answer is, okay?
You can just keep the V minimum then.
All right, that sounds good. So we have MGH min equals 1/2 MV minimum squared plus MGHB.
You smell good.
So now we need to substitute. Or actually, let's solve for H min, then we'll substitute. Okay? So H min. So notice here again, as it always happens, that the mass cancels out. Okay? Equal opportunity roller coaster.
So Vargas, if we substitute first, we get the gravity to cancel out too.
Hold on.
Mitchell,
So-
did you just say gravity doesn't discriminate?
So let's put, let's get the G away from H min, so we're going to divide through by G as well, okay?
No.
So 1/2G V min squared plus HB.
Wait, where'd you get G from? On that one.
This
Oh, you
G.
divide.
So I divide both sides by G. This G cancels out. This G joins the 2 on the bottom.
Got it.
And
Okay?
when you square the V squared, you
So this V minimum is this guy here. So that's 1/2G. We square this. We're going to get G times R plus HB is what?
The height at the top of the
It's the height at the top of the circle, but what is that?
radius.
2R.
2R.
Right? Because it's the diameter of our circle.
What? Diameter is 2 times.
So this is H min.
From the last time we ever had to use diameter.
So we have 1/2. The G's cancel out. So we have 1/2 R plus 2R equals H min. And now we can combine the R's. So R times 1/2 plus 4/2.
5 halves are.
So we have 5/2 R is H min.
That is beautiful, Vargas.
So can we just like remember that for every single problem?
No.
Your wish.
What if there's a formula for
So
everything?
what test are you gonna cheat on today?